So we're on to the final lesson of Chapter 4, Section 4.5. What we did in the first part of 4.5 was just looked at solving rational equations. Now we want to look at using rational equations to solve application questions. So here we have a warm-up question where you're actually given the rational equation. So given this equation, take a moment to read through the question. Take note of what values you're given. Is this a t value or is that a c value? Substitute it into the equation and then solve for the other variable. So you should pause the video now, take some time to finish this question, and then restart the video. All right, pause it now. So now that you've read through the question and you've completed it, you've noticed that this 3.75 grams per liter was the salt concentration. So we're substituting that in place of the C, and then we solve the equation. So you multiplied the denominator, the 25 plus t, on both sides of the equation. And when you do that, then on the right-hand side, they cancel out. On the left-hand side, we'll need to distribute that 3.75 into the parentheses. After we distribute, then we can collect the like terms to the same side of the equation. So I'll subtract the 3.75t so that I'll collect the t's on the right side of the equation. And finally, we divide both sides by 6.25, and that will give us our t value. So we record the conclusion that the salt concentration in the tank will reach 3.75 grams per liter in 15 minutes. All right, if you had questions with this, you can go back and replay or try it again, but we'll move on to the next question. In question number 2, Rima has bought a case of concert t-shirts for a certain amount of money. She kept 2 of the shirts for herself and then sold the rest, and were given that price she sold them for. So she made a profit of $10 on each shirt. So this would be per shirt, including the ones that she kept for herself. Okay, so profit based on the total number that she originally purchased. We want to know how many t-shirts were in the case. So we need to start by defining a variable, and since this is what we want to find out, that's how we'll define our variable. Now, since in this question we know a profit per t-shirt, our equation needs to talk about individual t-shirts. So we'll have a few parts to the equation, and here's what it might look like. So if we take the selling price per shirt, and from that we subtract the price paid per shirt, that should give us the profit per shirt. So, the selling price per shirt, we know that the overall selling price was $560. But if we want it per shirt, we need to divide by the number of shirts that were sold. If n is the number of shirts that were initially in the case, now what we have is n minus 2 shirts, because Rima kept 2 of them for herself. The price paid, well, the total price was $450, and that was paid for all of the shirts, so that's just going to be over n. And this will equal our profit of $10 per shirt. So we have a selling price per shirt, total price divided by the number of shirts sold, subtracting the price paid for all of the shirts divided by how many shirts were purchased. That was a price per shirt. That gives us our profit per shirt, which is what we were told in the question. So now we need to solve this rational equation. This is similar to what you did in yesterday's assignment, and so I'd like you to pause the video at this point, work through the solution, and then restart the video to see how your solution compares with mine. Pause the video now. So again, we begin by multiplying by the common denominator, which is n times n minus 2, the product of these two denominators. When we do that, now we can see there are some common factors that cancel out. The n minus 2's cancel out, the n's cancel out here, and then we can simplify our equation. So when I multiply everything out, notice on the left-hand side, because I was subtracting, and here I had an n minus 2, I was multiplying a negative 450 times that negative 2 to give me a positive 900. Easy place to make a mistake, to miss out that that's going to be a positive 900. Then I collected all the terms to the right-hand side of the equation. We have a quadratic equation that we could solve by factoring or by graphing. I'm going to do it by factoring just to review how to do it. And my first step is going to be noticing that there's this common factor of 10. So I'm going to multiply everything on both sides by 10 just so I have smaller numbers to work with as I factor. So as I go through and solve by factoring, I end up with these two values, but then I need to think again about what did my n represent. It was a number of t-shirts in the case. Well, I could have had 18 in the case, but negative 5 t-shirts just doesn't make any sense in the context of this question. So we're going to reject that answer. We call that an inadmissible solution because it doesn't fit in the context of the problem. And don't forget, we do need to write a sentence answer. So there we go. Again, if you had questions with this problem, take some time to work back through it. Replay the video if you need to. We'll go on to question number 3. In this question, we have 2 liters of water, and we want to add some pure lemon juice to these 2 liters of water to make a lemonade solution that contains 20% lemon juice. So we're going to use a proportion in how we set up our equation this time. Again, we need to begin by defining our variable. So I'll let x represent the amount in liters of pure lemon juice that we'll be adding. Now to set up a proportion has a ratio equals a ratio. So what my ratio is going to look at is that 20%. So that 20 over 100. And if I think about what that means, the 20 is talking about an amount of pure lemon juice. And the 100 is the total amount of the final juice that we'll end up with. So as I think about the meaning of the numbers in the numerator and denominator, that helps me with the other side of the proportion. Because the amount of pure lemon that I'm adding is a mystery, so that's my x. But the amount of juice I'm going to have at the end, well, that I also don't know, because I'm going to start with 2 liters of water, but then I'm adding x liters of lemon juice. So this will be my equation that I'll use. An amount of pure lemon juice over the total amount of the mixture equals the 20%. So 20 is the amount of pure lemon juice, the 100 is the amount of the total juice mixture. Again, pause the video, take a couple minutes to solve this equation, and then restart it to compare our solutions. Pause the video now. So half a liter of pure lemon juice will need to be added to the 2 liters of water to get the 20% mixture. If you didn't get this answer, make sure you look carefully back through the steps, multiplying both sides by the common denominator, canceling out those like terms, and then solving the equation that we get. If you need to replay, feel free to stop and do that. Otherwise, let's continue on to question 4. In question number 4, we have a boat that's traveling upstream and downstream. So upstream is when the boat is going against the current, so the water is pushing against the boat, slowing it down. Downstream is when the boat is going with the current, and so the current pushes the boat along so it goes more quickly. In this case, it takes the same amount of time, but we're traveling different distances. Going downstream, we can go 12 kilometers in the same amount of time it takes to go 8 kilometers upstream. We're asked to find the speed of the current. So let's use that as we define our variable. Now I chose to let r represent the speed of the current. I decided not to use s because sometimes my s's start looking like 5s and I get confused in the question. So r's I'm less likely to get confused with, and I choose r because I think of speed as being our rate. And so I'm using r to represent the rate of speed for the current. And again, we need to think about the distance between speed, the time, and the distance. So you'll recall that speed times time equals distance, although in this case, since we know that we have the same time, what we want to do is set up an equation where we'll have time equal to time. And so rearranging this, we get time is equal to distance over speed. And so for this question, we're going to look at the time upstream compared to the time downstream. And using this relationship, I can look at the distance upstream is 8 kilometers over speed. Now, the speed is going to be a combination of the speed of the boat and the speed of the water. So again, since we're going upstream, we'll take the speed of the boat and we'll subtract the speed of the water. Going downstream, we have a distance of 12 kilometers over the speed of the boat plus the speed of the water. And so this sets us up for solving to find out what is the speed of the current. Again, pause the video, complete your solution, and then restart the video to compare your solution with mine. Pause the video now. So as I complete the solution, I get that the speed of the current is 3 kilometers per hour. Again, multiplying both sides by the common denominator, canceling out like terms between the common factors between the numerator and denominator, and then solving. Go back and rework this if you need to, but if not, let's go on to the next example. Our final example is a rate of work problem, and I have to admit, of all the different types of applications and word problems there are, this type is one of my least favorites. I tend to confuse myself as I work through these, so we'll go through it slowly and handily enough I can stop and re-edit if I make a mistake as we go along the way. But hopefully I can give you a strategy that's going to be helpful. The strategy that the textbook uses is slightly different. So you can look at that if you're not happy with the way I describe it, but give some time to consider the way that I think through this type of question. So what's happening here is we have Billy's dad can do a certain amount of work in 3 hours. If Billy helps his dad, then it's going to take less time. Well, we want from this information to figure out how long is it going to take Billy to do this complete job if he works by himself. So again, let's start by defining our variable. So I'm going to let W represent the time it will take Billy to complete the yard work on his own. Again, I'm not using B for Billy because my B's sometimes look like 6's and I need to be careful that I don't confuse myself. Now in the previous question, we had a speed, time, and distance question. And I like to think of this question in a similar way. So let's start with that relationship where we have speed times the time equals the distance. So I want to use a similar idea where I'm going to think of the rate of work times the time worked equals an amount of work completed. So if I use this idea, then I need to think about a rate of work, the amount of time, and this is what we want to find, right? We want to find the time it's going to take Billy to complete the yard work on his own, and that's going to give us a total amount of work. So let's think about Billy's dad's rate of work. Well, since Billy's dad can complete the full job in 3 hours, then what we could do is we could say that he can complete 1/3 of the job per hour. Then when we think about Billy's rate, we don't know how much time it takes him to do the job by himself, but we've represented that with W. So the fraction he can complete in an hour is 1/W. So here, take a moment to think about it. His dad took 3 hours, so it was 1/3 of the job, so 1 out of 3 parts in 1 hour. For Billy, if it's going to take him W hours, then 1 over W per hour is the rate that he's going to be working at. So now let's look at the amount of work that they can get done. So we'll have Dad's amount, and we're going to add to that the amount that Billy can get done. And that's going to equal the total job, or the total amount. The total amount of work that was done. And so if we think percentages here, the total job is 100% of the job. So my right-hand side is going to be 1 because in decimal form 100% is 1. Then since I'm looking at amount that Dad does, the amount is going to be his rate times his time. Well, we know Dad's rate is 1/3 of the job per hour. And his time, in this question, we're told that they work together for 2 hours. So his time is going to be 2 hours. To that we'll add Billy's amount. His rate is 1 over W. His time is also 2 hours. And so this gives us an equation that we can solve. Just to clean it up a little bit so we don't have fractions multiplied to numbers, this is the same as 2/3 plus 2 over W equals 1. So this will be the equation that I'll use to find out how much time would it take Billy to complete this job on his own. Pause the video or replay it if you need to get the idea of where this equation came from. Work through the solution and then compare your answer with mine. Pause the video now. So here you have it. Working on his own, Billy can complete the yard work in 6 hours. All right. With those examples, you should be set to work on the assignment that is listed on Edmodo. So those 6 questions take some time to work on it. So hopefully you're viewing this video at home in the evening and you can save working on the questions until in class, where you can get some help and support from others and you can give some help to others as well. All right. Work hard at this, it's worth your time.